Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the sixth lecture of grade first year. The chapter name is thermochemistry and the topic name is first law of thermodynamics and the pressure volume work. First of all, what is first law of thermodynamics? The first law of thermodynamics states that energy can neither be created nor destroyed, although it may be transferred or changed from one form to another. It is also called as law of conservation of energy. Why? Why it is called as law of conservation of energy? Because the energy is neither creating, the energy is neither destroying from the system or surrounding. We can neither create or add the energy, and we can neither destroy the energy. So there is no involvement of energy here. It means that energy remains conserved in the system or in the surrounding. Energy will be conserved. So this is called as law of conservation of energy, and this law was first presented by Willard Gibbs in 1873. So the energy can neither be created nor destroyed, although it may be transferred or changed from one form to another. The total energy of the system and its surrounding is conserved. For example, an electric bulb. You know that the bulb produces light. It means that it has light energy. How light energy is produced? First, when we switch on or when we on the switch, it contains electrical energy. And immediately that electrical energy will convert into light energy. So an electrical bulb converts electric energy into the light energy. Similarly, a ball in the atmosphere, when we throw out in the atmosphere, it contains potential energy, that is kinetic energy get converted into potential energy, and when that ball will fall down from atmosphere to earth, the potential energy will convert to kinetic energy. So this is the first law of thermodynamics. The energy will remain conserved, although it is transferring from one form to another, that is from potential energy to kinetic energy, or from kinetic energy to potential energy, or from electrical energy into light energy. That forms are transferring, but energy overall remains conserved. Energy is exchanged between the system and the surroundings in the form of heat and work. As you know that energy is in the form of heat and work. A system may lose energy to the surrounding in the form of heat, but at the same time the same amount of energy is absorbed by the surroundings. एक वक्त में एक सिस्टम एनर्जी लूज भी कर सकता है, और जब सिस्टम एनर्जी लूज करेगा इट मीन्स दैट एनर्जी और दैट हीट विल बी एब्जॉर्ब बाय द सराउंडिंग. जब सिस्टम ने एनर्जी लूज की, सराउंडिंग ने उस एनर्जी को गेन किया इन द फॉर्म ऑफ हीट. Hence, the amount of energy lost by the system is equal to the amount of energy gained by the system. The work done by the system equally affects the work done by the surrounding. Similarly, the work done by the surrounding equally affects the work done by the system. So the first law of thermodynamics states that the internal energy of a system changes from an initial value to a final value due to heat added and work done by the system. I have told you all these things, that the heat or energy exchange is in the form of heat and work. Initial state change to final state, and overall energy will remain conserved, only it may transfer or change from one place to another, or from one form to other. It is generally denoted by del U, that is change in internal energy. This is del U, or del E is the change in internal energy, as you have studied in internal energy, that it is denoted by del U or del E. This is the change in internal energy, which is equal to amount of heat provided to the system, that is Q, minus the amount of work done by the system, that is W. In some books there is Q plus W. The Q plus W shows what? The difference between the two equations is that first one, in which Q minus W is written, it means that work is done by the system. This work done involves system. That system is doing work on the surrounding. First equation shows work done by the system, while the second equation, that is Q plus W, means that work is done on the system. The system is a specific thing, a specific part of the universe which is generally positive. But when system will lose energy and it will work done, the work is done on the surrounding by the system, it means that it will become negative. And when there is work done on the system, it means that it become positive. So we can write it as Q minus W or Q plus W. So in this general equation, the Q is positive and W is negative. Q is positive when the system gains heat and negative when the system loses heat. W is positive when work is done by the system and negative when the work is done on the system. There are generally two parameters, that is work and heat. First, work done by the system on the surrounding. Now system is doing work on the surrounding. It means that W will be negative. In the second case, work done on the system by the surrounding. Now the surrounding is doing work on the system and system get absorb heat. It means that W will be positive. In the third case, heat absorbed by the system from the surrounding. It means that system is absorbing heat. Again, Q will be positive. When surrounding will do work on the system, it means that the system is gaining heat and energy, it will be positive. And when heat will be absorbed by the system, it means system is giving heat to the surrounding is giving heat to the system. It means that again heat is absorbed and the Q is positive. When heat is absorbed by the surrounding from the system, it means that now system is doing work and losing energy and surrounding is absorbing heat. It means that the Q will now negative. Here is an example that 100,000 joule of thermal energy flows into a system. 1000 joule means the energy, it means that it is Q. At the same time, 400 joule of work is done by the system, that is W is equal to 400 joule. As system is doing work is done by the system. It means that system is doing work on the surrounding. It will be negative. So what is the change in the system? Internal energy U. So del U is equal to Q minus W. Because work is done by the system. When system will do work, it will become negative. So Q minus W, you will put the values and get the answer. The next topic is pressure volume work. The only type of work in thermodynamics is the work of expansion or the pressure volume work. This is the work done when a system expands against an opposing pressure. It is actually the concept about pressure and volume. I have told you in previous classes that pressure and volume are inversely related. When the pressure will be less, the volume will be increased, and when the volume will less, the pressure will increase. Consider a gas contained in a cylinder of cross-sectional area A with a weightless and frictionless piston. The pressure on the piston is P. हम लोग सबसे पहले एक सिलेंडर लेंगे, यानी एक कंटेनर लेते हैं जिसका एरिया A है और उसके साथ हमने अटैच किया है फ्रिक्शनलेस पिस्टन और वेटलेस पिस्टन. जो प्रेशर उस पिस्टन पे अप्लाई करेंगे वो P है. एज यू नो द फॉर्मूला ऑफ प्रेशर इज फोर्स पर यूनिट एरिया. प्रेशर का फॉर्मूला है फोर्स पर यूनिट एरिया, और जब हम फोर्स को साइड पे कर देंगे तो ये बन जाएगा प्रेशर मल्टीप्लाइड बाय एरिया. That is, work is equal to force multiplied by distance. Now the distance is denoted by del L. The force, here we are denoting force with work. Now work is equal to pressure multiply area multiply the distance del L, the distance through which the piston moves during expansion. This is that distance. So pressure multiplied by area multiplied by del L, which is change in the distance. The area multiplied by change in distance is equal to change in the volume. As with the change in area, the volume will change. With the increase in area, the volume will increase, and with the decrease in area, the volume will decrease. So, area and distance is directly proportional to volume. So, A multiplied by del L is equal to del V. So, here now when we write the equation of work, it means that W is equal to P del V. What is del V? Del V is area multiplied by del L. That is area and change in the distance through which piston moves is directly proportional to change in volume. Greater the area, greater will be the volume. Less the area, less will be the volume. Similarly, greater the distance, greater will be the volume. Less the distance, less will be the volume. So W is equal to P del V. Here you learn about these equations that change in internal energy is equal to Q minus W. Q is the heat flows and W is the work done by the system. Now in case of W, we will put value P del V. So del U or del E can be equal to Q plus W and Q minus W. In case of Q minus W, it will be Q minus P del V. In case of Q plus W, it will be Q plus P del V. I am telling you these relations with change in internal energy, and I am deriving the equations of work, that is pressure, volume, work. I have derived the value of work, that is P del V. P is actually the pressure, which is equal to force per unit area. Then I have separated the force and multiplied pressure multiplied by area. That area then again multiplied with the distance through which piston moves. So the area and the distance through which piston moves, that is del L, is directly proportional to del V, that is change in pressure. So the equation of work was P del V. Now in this equation of the first law of thermodynamics, that is del U is equal to Q minus W or Q plus W, I am putting values of W, that is P del V. When work is negative, that is Q minus W, we will put the value of W, that is del E Q minus P del V. It means that work is done by the system. And when it will be Q plus W, that is Q plus P del V, it means that work is done on the system. So in general, del E means change in internal energy is equal to heat absorbed by the system, that is Q. So the unit of work and heat is in SI system are Newton meter or joule. This was all about pressure, volume, work. Here is an example. Thank you so much.